Today we are going to learn Geography of Class 6. The chapter number 4, Rotation and Revolution. Students, in your previous class, you have already known or already learned about what is rotation and what is revolution. We are going to study elaborately about this topic in this chapter. So, shall we start with it? Okay. Rotation, Earth's daily movement. The daily movement of the Earth on its imaginary axis from west to east is called rotation. It is similar to the spinning of a top. It takes 24 hours to complete one rotation. This period of Earth's rotation is called an Earth day or a solar day. So, rotation is the movement of the earth on its imaginary line. The earth's move or earth's rotate from west to east, and it takes only 24 hours to complete a one rotation. The axis of earth is tilted at an angle of 66 and a half to its orbital plane, or the axis is 23 and a half degree from a line perpendicular to a orbital plane. This is known as tilt or inclination of the Earth's axis. When the Earth rotates on its axis, one half faces the sun, is lit and has day. The other half is tilted away from the sun, remains in darkness and has night. A circular line that divides the lit part of the earth from the dark half is called the circle of illumination. Now, our earth is little tilted. Now, because of this tiltness, the earth is divided into two parts. The one part is facing towards the sun, they have day, whereas other part which is against or opposite to the sun has night. And the line between this part which divides the dark half to the light half is called the circle of illumination. Let's see the effects of Earth's rotation. The alternate phenomenon of light and darkness we refer to as day and night is caused by rotation. When the Earth rotates on its axis, one half of it faces the sun as day and the other half is tilted away from the sun, remains in the darkness and has night. So we have already discussed about the one half which face towards the sun has a day and the one half which away from the sun has a night. Just before the sunrise, there is a period of diffuse light called dawn. Similarly, at the time after the sunset, there is a reddishness in the sky. This phenomenon is called dusk. Now, what is dusk? Dusk is a period when there is no complete day or when there is no complete night. It is between the proper day and proper night. When sun arises, there is a little diffusion which is called dawn, and when the time after the sunset, there is a redness in the sky, and that redness is called dusk. The earth gets its peculiar goid shape, which is bulging at the equator and flattening at the pole due to rotation. Its mass expand at the equator because it spins faster there. The centrifugal force generated by rotation causes the bulge of its rocks at the equator. Tides are the daily rhythmic rise and fall of sea water and its level. They are caused when the sun and the moon exerted their gravitational pull towards the westward progress of these tides in the world's ocean and along the coastline is a result of Earth's rotation. Now, when Earth rotates, there is a high tide and there is a low tide, as you have already learned in your class 5th. 4. Reflection of winds and ocean current occurs due to Coriolis force, which is generated as a result of rotation of the earth. Winds and ocean current get deflated to the right in the northern hemisphere and towards the left of their movement in the southern hemisphere. Earth's rotation gives us a sense of direction. The earth rotates from west to east, so the sun seems to rise in the east and set in the west. Other heavenly bodies also appear to rise in the east and move in an arc across the sky and set in the west every day. This phenomenon can be compared to what we see. When we look out of the window of a moving train, it appears to us that trees, telephone poles, buildings on either side race past in the opposite direction. Actually, they are stationary and it is the train that is moving. Now, whenever the earth rotates, it gives the sense of direction. Basically, earth rotates from west to east, and that is why sun rise from east and set in the west. And same thing happened with other heavenly body. They rise in the east and move towards to the west. And here they have given the example of train also. When trains move, we see the things move opposite towards the train. Revolutionary Earth annual movement. The Earth revolves around the Sun in a fixed elliptical path called orbit. The movement of the Earth around the Sun in its orbit in an anticlockwise direction is called revolution. Now, what is revolution? Revolution is the Earth evolve around the Sun in its fixed path, or we can say in a fixed orbit. It is called revolution. The Earth revolves around the Sun at a speed of 1 lakh km per hour, or we can say 30 km per second, rotating on its axis at the same time. While Earth is revolved around it at the same time, the Earth rotates itself also. Now, the period taken by the Earth to complete one revolution is called a calendar or the Earth year. A year has 365 days and 6 hours. This is why we call revolution an annual motion. For convenience in making the calendar, the 6 hours are added up to become 24 hours as an extra days. The additional day is also called a leap day. After every 4 years, the 6 hours added up to the month of February. Thus, it has 29 days instead of the usual 28 days. This is called a leap year. Thus, a leap year has 366 days. Basically, when one revolution is completed, it becomes a Earth day or a calendar or a year. And in a year, there is a 365 days and 6 hours. These 6 hours is collected together and every 4 years it added to the month of February. So that is why sometime February has 29 days and sometime it has usual 28 days. When February has 29 days, that year is called leap year. And leap year, the days become 366 days. Effects of revolution. Phenomenon of season. A season is a division of the year marked by specific change in weather condition, temperature, and in duration of days and nights. The four seasons, spring, summer, autumn, and winter, are closely related to the position of the earth in its orbit around the sun. They are caused by the inclination of the earth's axis and its revolution around the sun. Each session occurs for approximately 3 months. Now, because of revolution, Earth has four types of season, that is spring, summer, autumn, and winter. It also affects the day and night of the Earth also. And this is all because of the inclination of Earth's axis. Now, and each season change approximately after 3 months. This also caused the phenomenon of solstice and equinox. Solstice occur when the sun is at its greatest distance from the equator. Solstice is derived from two Latin words. Sol means sun and sister to cause, stand still. Hemisphere which is inclined towards the sun receives more heat and light than the other which is away from the sun. Now, One of the phenomena of revolution is it cause season. The second phenomenon is it cause solistic as well as equinox. So what is solistic? Solistic occur when the sun is at great distance from the equator, or we can say when the sun is away from the equator, it becomes the solistic. Now the hemisphere which is inclined towards the sun receive more heat, whereas the hemisphere which is away from the sun receives less heat. Equinox means the equal day and equal night. The word is derived from Latin word equi, comes from equus, and nox days, nox. Days and nights remain equal in both hemispheres, whereas equinox means a equal day and night. And is whereas solistic means there is a variation between day and night. Sometimes days are longer, sometimes nights are longer. Let's see what is summer solistic. The northern pole is inclined towards the sun. Area beyond the Arctic get 24 hours of daylight. Areas beyond the Antarctic Circle are in complete darkness for approximately 3 months. In the northern hemisphere, days are longer than nights. When, first of all, what is solistic? Solistic is when the sun is away from the equator, right? Now, there is a two type of solistic. One is summer solistic, another one is winter solistic. And what happened in summer solistic? In summer solistic, the northern pole is inclined towards the sun, or we can say little bit tilted towards the sun, and it that area get 24 hours of daylight. So in northern pole there is an Arctic. If we go to the south, the circle is called Antarctic. So in that way the Arctic circle gets 24 hours day, whereas the Antarctic circle, which is away from the sun, gets 24 hours night, or it approximately take 3 months. Okay, and that Antarctic live in a 3 months of darkness, whereas northern hemisphere lives in a 3 months of days. The conditions are reversed from the southern hemisphere. It is summer in the northern hemisphere and winter in the southern hemisphere. 21st June is known as the summer solstice. It is the longest day and the shortest night in the northern hemisphere. The rays of the sun falls vertically at the Tropic of Cancer. Now, what is the condition? But the condition become reverse. Because of the inclination towards the sun, the north pole receives summer season, whereas the southern pole, which is away from the sun, receives winter. Why it receives winter? It's a simple, because for continuously 3 months it lives in a darkness, whereas northern hemisphere for continuously 3 months it lives in a day nights. And the 21st June is the summer solstice, because in that day, because in that date the day are longest and the night are shortest, and on that time the sun falls vertically at the Tropic of Cancer. Let's see winter solstice. Winter solstice exactly the opposite of the summer solstice. In winter solstice, the south pole inclined towards the sun, whereas the north pole is away from towards the sun. In southern hemisphere, there is a summer, and in the northern hemisphere, there is a winter, because the same situation, the south pole is inclined towards the sun. Now, the ray fall vertically towards the Tropic of Cancer. In summer solstice, the ray falls vertically towards the Tropic of Cancer, whereas in winter, the rays fall vertically over the Tropic of Capricorn. Now, the greater part of the southern hemisphere gets the ray of the sun, so days are long and nights are short in the southern hemisphere. In the northern hemisphere, nights are longer than days. The area above the Arctic remain in the complete darkness for about 3 months. area beyond the Antarctic gets 24 hours a day. 22 December is then known as winter solstice. Now, when winter solstice happens? Winter solstice happens on 22 December. It is the exact opposite of the summer solstice. Once again, I am going to tell in summer solstice, North Pole is inclined towards the sun, whereas South Pole is away from the sun. Whereas in winter solstice, South Pole is inclined towards the sun, whereas North Pole is away from the sun. In summer solstice, the sun rays vertically fall at Tropic of Cancer, whereas in winter solstice, the rays of the sun fall vertically over the Tropic of Capricorn. The summer solstice is happen on 21st June, whereas winter solstice happens on 22nd December. In summer solstice, the North Pole receives more day, whereas more daylight, whereas South Pole receives darkness for 3 months. In winter solstice, the North Pole receives daylight. South Pole receives daylight, whereas North Pole receives darkness for 3 months. Let's see an equinox. What is equinox? Equinox is a equal day and equal night. Let's see, there is a two type of equinox, that is spring equinox and autumn equinox. Let's see what is spring equinox. None of the pole is inclined towards the sun. The rays of the sun fall vertically at the equator. All the places have equal length of days and night as both poles receive the rays of the sun. It is a spring in the northern hemisphere and autumn in the southern hemisphere. The day 21st March is known as spring equinox. It is known as vernal equinox. Now, the 21st March is a day when spring equinox happened. It also called vernal equinox. In this, none pole, matlab no pole receives inclined towards the sun. All the places have equal day, equal length of day and equal length of night. And it is a spring. If it is a spring in the northern hemisphere, then there is a autumn in the southern hemisphere. Let's move on to the autumn equinox. Autumn equinox is exactly opposite of spring equinox. Now, in autumn equinox also, no pole incline towards the sun. Same, the sun rays fall at the equator. In above also, the sun rays vertically fall at the equator. In autumn equinox also, the sun rays vertically fall the equator. Here also, all places receives equal length of days and nights, but here situation is opposite. In autumn equinox, northern pole is in autumn. If northern pole is in autumn, then the southern pole receives springs, and this thing happens on the 23rd September, which is also called autumn equinox. Okay, now this cycle of season is repeated year after year. So every year, summer solstice, winter solstice, spring equinox, autumn equinox receives. As you can see here, this is the North Pole. Now here 4 earths were made, and this is the sun. Now here, this is a 21st March, where north hemisphere receives spring, and in here, as you can see here, the whole north and south pole does not receive any day or any night. But if you move here in this part, the northern pole little bit inclined towards the sun, whereas as you can see, southern pole is away from the sun, and this happens on 21st June, and in that time summer solstice happen. Now let's move on to this. The equinox do not always occur on the same date each year because of the difference of 6 hours in a revolution time, 36, 365, 1/4 days, and length of a calendar, year 365 days, the extra 6 hours are adjusted in the leap year. So this equinox does not happen on exact day because of this 6 hour difference. Now, let's see distribution of heat. The equator and the region around it receive the direct rays of the sun. Places located on the equator have hot weather throughout the year. The seasonal variation in temperature is very less. At the equator, it has the same weather all year. Now, the region which is around the equator always receives the direct ray. As a result, there is a very less season variation occur, and most of the time the weather throughout the year is same. As you can see here, the equator in this, as you can see in this, the equator receives direct sun rays, and throughout the year the weather almost is same. Now, heating is instant in the tropic on either sides of the equator. As we move away from the equator, sun rays falls at the slant and travel through a longer distance in space. As the same amount of heat rays are spread over a large area, the heating of the Earth's surface is less tense. When the northern hemisphere tilted towards the sun, it experienced summer, and the southern hemisphere tilted towards the winter experience winter. However, when the northern hemisphere is tilted away from the sun, it experiences winter, and the southern hemisphere experience summer. As we have already learned in solstice, summer solstice and winter solstice. So when summer solstice happened when northern hemisphere tilted towards the sun, and when winter solstice happened when northern hemisphere away from this sun. Okay, now variation in the length of day and night. Revolution and inclination of the earth's axis causes unequal day and nights. Because of revolution, because of inclination, the days and nights always unequal. And study the diagram carefully and note how the number of days, hours in each hemisphere varies at different latitude in summer and winter. Summer has longer days and shorter nights, and winter has longer nights and shorter days. Equator has 24 hours of days and 24 hours for night. That's all for today. Have a good day. Have a nice day.